Hi, it's Professor Adam. Let's talk about titrating a weak base with a strong acid. Here we have the titration of a weak base with a strong acid with four distinct regions. The initial pH before any base has been added, after the equivalence point when the addition of the strong acid slightly lowers the pH and causes a buffered system to form, the equivalence point when the concentrations of the initial acid and the added base are equal, and after the equivalence point when all the base has been consumed and excess acid causes the pH to significantly decrease. Our first step is to calculate the amount of base needed to reach the equivalence point. We start with 40 milliliters of 0.025 molar weak base, which we will be titrating with 0.100 molar strong acid. The equivalence point will be when we have equal concentrations of acid and base. We can then calculate the concentration of acid needed as 10 milliliters. The initial pH is determined by Kb, the base dissociation constant, and the initial concentration of the base because initially the system only contains the weak base. This follows this equilibrium. We'll omit the reaction table for now, but the equilibrium concentrations can be calculated as so, with the hydroxide concentration being 6.3 times 10 to the minus 4. The pOH can then be calculated as 3.2, and pH will therefore be 11. After we start to add base, we create a buffer-like system and can make use of the Henderson-Hasselbalch equation to calculate the solution pH based on the unreacted base conjugate acid quotient. Because the equivalence volume is 10 milliliters, then if we add 5 milliliters of strong acid, half the equivalence volume will be consumed. A table of relative concentration before and after addition can be made, and using the quotient, the pH can be calculated as 9.2. When the concentrations of acid and base are equal, and all the base is consumed by the acid, we have reached the equivalence point. What remains after titration is a weak acid solution described as so. The concentration of BH plus has changed and is no longer 0.025 molar, and so the concentration changes as it has been diluted by acid from the burette. X can then be calculated normally, giving in this case a pH of 5.5 at the equivalence point. The pH at the equivalence point is always below 7 for a weak base strong acid titration because the base is converted to its conjugate acid at the equivalence point, which is a weak acid. After the equivalence point, excess acid will cause the pH to gradually decrease. The added strong acid is much stronger than BH+, and so it is fair to say that the strong acid is more of a factor in determining the pH. Let's try and calculate the pH when 10.20 milliliters of strong acid has been added. This is only 0.2 milliliters more than the equivalence volume. For the hydronium concentration, we must consider the concentration of the added acid, the volume of excess acid, and the dilution factor, which is the total volume of the solution. We can then use the concentration of hydronium, which is 2 orders of magnitude higher than the BH plus earlier, to calculate the pH as 3.4 after the addition of 10.20 milliliters of strong acid. Let's check comprehension.